Right, so we're going to start by looking at section 6.2, part 1. Okay, we'll finish it up either later today or tomorrow. And this is on what's called unit circle trigonometry. So what I'm going to do is I'm going to draw a diagram just to show you kind of what the idea is of unit circle trig, and then we'll go from there. All right, so what I've drawn here is a circle. Inside the circle, I put an angle. The horizontal side on the positive x-axis is your initial, and the side going off in quadrant 2 is your terminal side. Well, the terminal side hits the edge of the circle somewhere. Every different angle would hit it at a different spot. Okay, it depends on what the angle is. But the terminal side will hit the edge of the circle somewhere. Any question on that? So the goal is when you put in this arc, you draw the arc starting at the initial side all the way to where the terminal side hits the circle. That point in green has a coordinate. You go left a certain amount, like if this is the origin, you go left and you go up. And there's a way to get to that point in green. That's the goal of unit circle trig. Figure out the coordinates for that point in green. And that's pretty much it. If you can figure out the coordinate, then you can do what you need to do. But that's the whole goal. You've got to figure out the coordinate for where the terminal side hits the edge of the circle. Now, some angles are easy to find, some are a little harder. Let's take a look at, let me get rid of this one. And let's look at a 90-degree angle. Okay, so remember 90 is when you go straight up. So if I were to draw my angle, the terminal side would be right here. That would be the point. Now, this is on a unit circle. What's a unit circle again? It's a circle with a radius of 1. So to get to 90, if that's the origin, you went up and you stopped right on the edge of the circle. How far is it to go from the center to the edge of the circle? One unit. 1 unit. Whatever it is. It could be 1 foot, 1 inch, but whatever it is, it's 1 unit from the center to the edge of the circle. So if you go straight up to get to 90, do you go left and right at all? No. So what do you think the coordinate would be for 90 degrees? Yep.
0, 1.
0, 1. That's the coordinate for 90 degrees. It's always the coordinate. That never changes on a unit circle. Now, how about 180? You're still moving 1 unit from the center, but now you're not moving up. 180 is moving left. 10. -10. Yeah. So -10, that's the coordinate for 180. I didn't draw the whole thing, but that'd be your initial. That's your terminal. And the point would be right there. Okay, 270. Initial, terminal. That's where the point for 270 would be. So what's the coordinate for 270?
0, -1.
Yeah, 0, -1. And then 0, well, your initial would be right there. Your terminal would be right on top of it. And what's the coordinate for 0 degrees?
1, 0.
That one is 1, 0. Okay, so those are the 4 easiest coordinates to find because all of the coordinates have a 0 and a 1, or a -1. So 0s, 1s, -1s. Any questions on how we found those 4 coordinates? Okay, and that's what would be important if we were going to do unit circle trig. Not the angle, the location of the angle. That's what you have to figure out. Where is it as a coordinate? Okay, and I think I write that all out, but if you understand what I just said, you really don't need to write it. I'll show you the part you should write. Okay, so for certain angles, we can sketch them in a unit circle, and then we can find the coordinate. That's what I just explained. So that's the part that's important. The coordinate allows you to find the 6 trig functions of the angle. Which angle? Well, it depends which coordinate you're using. Right now, we only know 4. We did 0, 90, 180, and 270. So once you find the coordinate for one of those 4 angles, then you can do all 6 trig functions of that angle. And we're going to talk next about what the 6 trig functions are. Now, notice I said up here, I said certain angles. When I say certain angles, if you want me to be specific, I mean any angle that's a multiple of 30 or 45. If you said to me, well, what if I want to draw a 17-degree angle and find the coordinates for it? I don't know exactly how you would do that. Okay, that's not, at least not as exact answer. That's a little harder. So the ones that we can do are anything that's a multiple of 30 or 45. So numbers like 30, 60, 90, 120, 150, those are all multiples of 30. 45, 135, 225, 315. All those numbers I just said were multiples of 45. Okay, so there's only certain angles that you can really do with unit circle trig easily. Right? And that's the 30s and the 45s. So I'm going to show you the 6 trig functions. And if you've done like SOHCAHTOA, people know what I mean, like opposite over hypotenuse, adjacent over hypotenuse. If you've done that, that's called right triangle trigonometry. That's a little different. This is unit circle trigonometry. It's actually 2 different ways of doing the same thing. When you do the 6 trig functions on a unit circle, we don't use the words opposite and adjacent and hypotenuse. What we use is a coordinate, an x, a y, or both. Right? So the definition of sine, if you're doing unit circle trig, is it is the y value of the coordinate for your angle. So it's the y value. If you want to know the cosine of an angle, you find its coordinate, and it's the x value. Okay. And the third one, if you want to know the tangent of an angle, you find its coordinate, and you take the y value of the coordinate and divide by the x value. Below them, I put the abbreviations. So from now on, I'll abbreviate them. Sine, S-I-N, cosine, C-O-S, tangent, T-A-N. It's just the first 3 letters of each trig function. If you look at your calculator, sine, cosine, tangent. They use the abbreviations as well. Okay. Now there's 3 other trig functions. The cosecant, the secant, and the cotangent. And the reason I wrote them like this, I put 3 on the left and I put 3 on the right, is because I wanted sine to be across from cosecant. I want cosine across from secant and tangent across from cotangent. Because there's a connection between the ones that are across from each other. Okay. Now, right now, y isn't a fraction. Okay. But if I wanted to make y a fraction, I could put it over what number? I could put it over 1. You don't have to write this, but pretend like there's an invisible 1 there. If you know the 3 trig functions on the left, to get the ones on the right, all you do is flip the ones on the left. So what do you think the cosecant would be based on just flipping the one that's right next to it? It would be 1 over 1. And how about the secant?
X over 1 over X.
1 over x. And the cotangent, x over y. Does anyone remember the fancy word for flipping something? It's the reciprocal. So these are all reciprocals. That's what you call them. Specifically, they're called the reciprocal identities. You flip one to get the other. So if you take the sine value and flip it, you get the cosecant value. What if you took the cosecant value and flipped it again?
You can get sine.
You'd get the sine back. So each time you flip it, it just changes it from one to the one that's next to it. If you flip the tangent, you get the cotangent. If you flip the cotangent, you get the tangent back again. So notice every one of these definitions is based off of an x, a y, or both. So that's why you have to be able to find the coordinate. If you can't get the coordinate, then you can't plug into any of those formulas. Okay, so the 4 angles that we talked about earlier have a special name. Those are called the quadrantal angles because they're on the axes, and the axes separate your plane into quadrants. So they're called the quadrantal angles. They're the easiest coordinates to find. They all have zeros and ones. Once we go over how to find some of the more complicated ones, people start to get the hang of that, but then they forget how to find the coordinates for these. These are the easy ones. So don't forget how to do them, or you can make a reference sheet. All right, so how do we actually do unit circle trig? Okay, there's 2 steps. Step 1, what have I been saying all along? You have to be able to find the what to do unit circle trig? The coordinate. You've got to find the coordinate, or the point. So find the point that represents the angle they give you in the problem. So if they give you 90 degrees, you should be thinking 0, 1. There's your coordinate. Now, sometimes they'll give you the coordinate. If they give you the coordinate, like they're going to do in the first problem, then you don't even need to worry about it. You already have it. But if they don't give it to you, then you need to find it. So that's step 1. And then step 2 is to take your x and y values from the coordinate and plug them into one of the 6 formulas. How do you know which one? They'll tell you. They'll ask you, they'll say, like, find the sine. Or the test might say, find the cotangent. Okay, they'll tell you which one they want you to do. In class, we'll practice all of them. Right? So we'll find a coordinate, and then we'll do all 6. Okay, so step 1, find a coordinate if you need to. Step 2, plug the coordinate into one of the 6 formulas. Okay, and as far as the notes for this part, that's pretty much it. The rest is just examples. Okay, and I think we might want to start part of 6.2 because it's very, very similar to the examples we're going to be doing. But I don't think we'll want to finish it. Then that'll give us a little bit tomorrow that's something a little different, and then we'll have the rest of the time to review. So we'll see. Okay. So it says the point given below corresponds to a certain angle. What angle does it represent? Well, you should be able to figure that out, but you don't need to. I don't care what the angle is here. It's one we talked about, but you don't need to know what it is. All you need to know is the coordinate, and you have it right there. There's your x, there's your y. So I want to find the 6 trig functions of this coordinate, which represents some angle on the circle. Okay, so let's start with the sine. Okay, the sine is equal to what value? Yep. It's the y, and in this case the y is 1, and that's it. You're done. That's what a question would be like on the test. You get a coordinate, you write the trig function. we're going to keep going and do all 6. Okay, cosine, what's that equal to?
0.
0. It's the x value, which is 0. And the tangent of our mystery angle that's represented by the coordinate 0, 1. The tangent is what over what? It's y over x. So that's a problem. So I'm not going to circle that because that's not the final answer. What is 1 divided by 0? Undefined. So make sure if you end up with 1 divided by 0, make sure you tell me what that actually is. Okay, now once we get the 3 on the left, what do we do with each one of them to get the 3 on the right? We flip them. Find the reciprocal. What's the name of the trig function that's the reciprocal of sine? Cosecant. Okay, they can't use the first 3 letters to abbreviate that one because they already use COS somewhere else. So they just do the syllable, cosecant. Okay. What's the cosecant? 1 over y. Well, y is 1. So if you flip it, pretend like it's 1 over 1, it stays the same. What's the next function? Secant. Right. And we're going to flip the cosine. So again, pretend like that's over 1 if you want. And what do you get if you flip 0 over 1? You get 1 over 0, which we just did. It's undefined. And the last one, COT, stands for cotangent. And now we're going to look at the tangent and flip it. So what do you get when you flip 1 over 0?
0 over 1.
You get 0 over 1, and that's okay. That comes out to a number. What's 0 divided by 1? 0. You take $0 and divide it to one person, the person gets nothing. And that's it. There's your 6 trig functions for that coordinate. That's the coordinate. What angle is that the coordinate for? 0, 1. That's 90 degrees. You don't need to know that to do this problem, but that's what it is. Okay, let's look at this one. So here's a coordinate. It's definitely not one of the quadrantal angles. How do I know that? Because it's got a square root of 3 in it, and none of the coordinates on the 0, 90, 180, 270, they all had 0s and 1s. So that's not a coordinate for an angle that we know. But the good thing is you don't need to know what angle it is. Right? Doesn't matter. You're just going to find out a bunch of things about the angle. Right? So sometimes it seems a little weird. You're going to figure out 6 things about an angle that you don't even know how big it is. But it's kind of like if you met someone on the street and you didn't know their name, you could describe a bunch of things about them and not even know their name. How tall they are, like what color shirt they're wearing, hair color, stuff like that. You don't need to know their name to do it. Same thing here. You don't need to know how big the angle is to describe a bunch of stuff about it. Let's start with the sine. Let's see. Okay. What's the sine? Yep.
Square root of 3 over 2.
Yep. Square root of 3 over 2. How about my cosine? It's 1/2. And the tangent, well, you basically got the calculation for the tangent written right above. The tangent is y divided by x. So just imagine putting a division line right there and do that out, and that's the answer for the tangent. Now, if you were to divide these, normally when you divide a fraction by a fraction, what do you do with the one in the bottom? Yeah, you multiply by the reciprocal. Well, if you take what's in the bottom and flip it and multiply, what would cancel out? Yep.
It would just be the square root of 3.
Yeah, it would just be the square root of 3 because the 2's would cancel out. If you flip what's in the bottom, it would become 2 over 1. You'd have a 2 in the top, a 2 in the bottom. So whenever I see 2 fractions that have the same denominator, and I'm dividing, I just cancel the denominators. I'm not going to put lines to it because if I do that, now it looks like I messed up my other answers. Okay. So I'm going to leave those because those are my answers. And all I'm left with is square root of 3 divided by 1, which you could just put square root of 3. Okay, so we got the 3 on the left. Kat, what do I do with all of them to get the 3 on the right?
For the first one, you flip it.
Flip it, yep, for all of them. Just flip them. Now, when I flip it, watch what happens. Square root of 3 ends up in the bottom. What's wrong with that? We're not supposed to divide by a square root. You can't leave it in the bottom. So how do you fix having a square root in the bottom? Yeah, what would you multiply by? By the square root. That's how you fix it. That's from algebra. Okay, so you multiply top and bottom by the square root. Now in the top, you get 2 times the square root of 3. In the bottom, you've got the square root of 3 times the square root of 3. Well, that's the square root of 9, which is what? 3. So anytime you get a square root in the bottom, you have to fix it. It's going to happen again, so we'll go through it another time. Okay, my next trig function after the cosecant? Secant. And this one's not bad because there's no root. It's 1 over 2. When you flip it, it becomes 2 over 1, or just 2. And the last trig function? The name of it? Yeah, cotangent. And you don't have to give me the final answer. Just tell me what I get when I flip what I'm supposed to flip. So which trig function are we flipping again to get your cotangent? You're just flipping the tangent. So let's just flip that. So if you flip tangent, what do you get?
You get 1 over the square root of 3.
Yep, we'll start with that. Now the only problem with it is we got the root in the bottom, so how do I fix it again? Multiply by the square root of 3. And what would that give me for the final answer? 1 square root of 3, or you could just say square root of 3 over 3. Okay. And that's the 6 trig functions for that coordinate, which represents some angle. Talk about later which angle it represents. Questions on that one? You want to hear a corny math joke?
Sure.
All right. I didn't even come up with this. Somebody in one of my other classes came up with it. Maybe they got it from somewhere else. I don't know. But why can't the function reach what's on the top shelf?
Because you can't.
You're kind of close, yeah. Because he can't reach it. Because he can't reach it. He can't reach it, yeah.
Yeah.
Because he can't reach it. Yeah.
I am ashamed.
I told you it was going to. I didn't come up with it. I just somebody else. Because he can't reach it. You got it now? Okay, look at this one. It says find the 6 trig functions of 90 degrees. What's different about this one than the last 2? There's no coordinate. So the fact that it's 90 degrees, that doesn't really help me. I need to know where 90 degrees is on the circle. So 90 degrees is when you go straight up. What's the coordinate when you go straight up? It's 0, 1. Well, wait a minute. If the coordinate is 0, 1, we just did that problem. So now all the answers would be the ones we just did in example 1a. From here, it's the same problem. Any question on how we got the coordinate? That's the only extra step. Yep.
Is there going to be any other ones except for 180, 270, 0, and 90?
Yes. Yep, anything that's a multiple of 30 or 45. But we haven't done that yet. Okay. Other questions on how we got that coordinate? All right. Let's do the 6 trig functions of 270. Okay, what do I need first? I've got to find the coordinate. It doesn't matter what the angle is, it matters where the angle is. So find out where it is. Which way is 270 on the circle?
Down.
It's down, right? What's the coordinate when you go down on the unit circle? Straight down. 0, -1. Okay, so now we should be able to go through those pretty quick. What's my sine? -1. My cosine? 0. And my tangent is when I divide y by x. Undefined. Right. How about my cosecant? What is it? It's -1. There's two numbers you can flip and they stay the same. If you flip 1, it stays the same. If you flip -1, it also stays the same. How about this one? If you're not sure, pretend like it's over 1. You're flipping 0 over 1 to get 1 over 0. That's undefined. So if you flip 0, you get undefined. If you flip undefined, you would get 0. And there's the 6 trig functions of 270. Any questions on those? Okay. That's kind of the same thing. Let's look at this one. The 6 trig functions of 7 pi over 2. Okay, what's a little different about this, the way they gave you this angle? Yeah?
It's in radians.
It's in radians. So what might we want to do with it? Yeah, you don't have to, but I think it's easier to think about if you know degrees. That's a basic one. It's a basic one times 7. Does anyone remember what pi over 2 is? Pi is 180.
90.
So this is 90, but it's 90 times 7. What's 9 times 7?
63. Kidding, 63.
63. And this is 630 because it's 90 with a 0 times 7. Now, that's what it is in degrees, but I don't really like that angle. What do you think I don't like about that?
It's above 360.
It's above 360, so there's something you can subtract from it to find something that's coterminal.
360.
Subtract 360. I get 270.
See, I knew where I was going with
You were just a little ahead.
this. Yeah.
So find the 6 trig functions of 270. We just did that. It's the same problem. So even though the question looked a little different, it's exactly the same as example 3, all the answers. So I'm just trying to show you, you can ask the same question in different ways, just by asking it in radians or giving an angle that's bigger than 360, and it turns out the same. Any questions on how we got 270? Okay, let's look at this one, -90. Okay, I like that it's in degrees, but what do you think I don't like about that angle? It's negative, so how can I fix it?
Adds 360.
Add 360. I get 270. So again, this is a third way of asking the same question. -90 is exactly the same as 270. We just did that in example 3. So always take something that's bigger than 360 or smaller than 360 and fix it. And then maybe it'll turn out to be something you've already done earlier. Okay? Especially with quadrantal angles, because there's only 4 to pick from. So you tend to see the same ones come up a lot. Okay. Any question on that one?
Yeah, you said anything like that's a. I can't think of the word.
Multiple of 30 or 45?
Yes. What if it's 30?
We haven't done that yet.
Okay.
We haven't done that yet. So let's continue looking at the beginning of the second part on unit circle trig. So we ended with Jake asking us about what if it's like a 30. I think it was Jake that asked us about what if it was a 30. And I said we hadn't done that yet. Well, that's the goal of this section. To be able to find all the 6 trig functions for angles that are either 30, that's the first one, pi over 3 is 60, and pi over 4 is 45. So we're going to look at how to find the 6 trig functions of those angles. And then if you can do the 30, the 60, and the 45, doing multiples of those angles is extremely easy. You just have to learn how to do those 3 first. Okay, and the last thing they put in this section is something that's kind of totally different topic. I'm not even sure why they really throw it in, but it's working a little bit with trig identities. We're going to spend like 5 or 6 lessons on trig identities later on. So it's a pretty big, there's a lot of stuff to it. You can kind of think of this as it's like an appetizer. It's to really get you excited for the trig identities that are coming. So we're going to look at something very, 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 very basic and simple. And then maybe you won't want the main course after that, but we got to do it anyway. So for today, let's just see if we can look at that part. We might have to finish that part tomorrow. We'll see. So what I've drawn inside there is I drew a 45-degree angle. Okay, we already did how to find coordinates for 0, 90, 180, and 270. So here's your 45. Initial side, terminal side. My goal is to figure out this. What is the coordinate for 45 degrees? Okay, and the way I'm going to figure it out is I'm going to make a triangle out of that picture in red. I almost have a triangle. I just need to add one more side. And I'm going to add it straight down from the 45. Okay, just like this. So I just made a triangle. Now, I didn't just make any triangle. That triangle in red is a special triangle. It's a right triangle, but it's also something else. Does anybody recognize what other kind of triangle it would be? Yeah?
Equilateral.
It's not equilateral, but you're on the right track. Yeah?
Hypotenuse.
It has a hypotenuse. I'll talk more about the hypotenuse in a second. The hypotenuse is really the radius of the circle, so we already know how big it is. Yeah?
Starts with an I, right?
Starts with an I.
Remember the
Isosceles. Yeah. So that triangle in red, I've got it bigger right here. It's the same triangle. This is a 45-degree angle. That's the angle that you had to rotate the terminal side up. Or instead of up, I could say counterclockwise. Well, if the bottom angle is 45 degrees, because we rotated that terminal side up, how do I know that that top angle is 45 degrees? Yeah?
Because they total, all the angles total will be 180, and you can subtract 90 and 45.
Yeah, they all have to total to 180. So if we know that that one's 90, because that's the way I drew it, and that's 45 because we said we had a 45-degree angle, then the one at the top has to also be 45. So 2 angles that are the same, that makes it isosceles. Now, one of the sides we already know. This side is the hypotenuse, but it's also the radius of the circle. So what's the radius of the kind of circle we're working with? It's 1. Now, unfortunately, that's not the coordinate. The coordinate is right here. How far right do you go? And how far up do you go? I need to figure out the length of those 2 sides in green. How far right, how far up. But how far right and how far up you go, if you compare those 2 distances, they're going to be what? They're equal, because that's an isosceles triangle. The sides opposite the angles that are equal are also equal. So I'm going to pick something to call that side. I'm going to call it x. Now, if the other side is the same, then I can also call that side x. Don't call it something different. It's not different. It's the same. And now we just have to solve for x. And once we know what x is, that's going to be how far right and how far up you go to get to 45 degrees. There's a theorem we can use when you know the sides in a triangle to find the length. Anyone remember the name of it? The Pythagorean Theorem. So the Pythagorean Theorem says one side squared plus the other side squared equals the hypotenuse squared. Well, that's one side squared plus the other side squared equals, what's my hypotenuse squared? Just 1. All right. Now on the left-hand side, I have x squared plus another x squared. So how many of them do I have? It'd be x to the 4th if you multiply. That's 2 of them. You have 2 of the x squareds. Okay. What could I do on both sides to get the x squared alone? Yeah, divide by 2. So now I have x squared equals a half, but I don't want to know x squared. I want to know x. So how do I get x? Take the square root. When you take the square root of a fraction, just do the top and do the bottom separate. What's the square root of 1? 1. And the square root of 2, we can't really take the square root of 2. And that's the answer, except for leaving something where we shouldn't. What? We got to fix the square root. How do we fix it? Multiply by square root of 2 over square root of 2. So the answer for x that we get is 1 times the square root of 2 over the square root of 2 times the square root of 2. That's the square root of 4, which is 2. Now that we know that number, we want to memorize it. We don't ever want to have to calculate it again. We just memorize square root of 2 over 2. That's an important number to write down or memorize. So square root of 2 over 2, that's how long, actually let me do it up here. That's the length of this side. And that's the height of this side. So does anyone have a guess what the coordinate would be to get from here to here? How far over do you go? And then how far up do you go?
1, 2. Is that what it is?
Well, how long is it from here to here?
2 square root of 2.
Can you just say it again?
Square root of 2 over 2.
Square root of 2 over 2. And then how long is it from here up to here? Same thing. That's the coordinate for 45 degrees. Okay, and again, now that we know that, we don't ever want to have to figure it out again like that from scratch. We just memorize the coordinate for 45 is root 2 over 2, root 2 over 2. There's only 3 numbers you need to memorize in this whole part. That's one of them, root 2 over 2. There's two other numbers, and if you know those 3, you can do anything you want with unit circle trig. So, any question on that coordinate? So it comes from the Pythagorean Theorem. That's how we got it. Okay, so that takes care of multiples of 45. Now, let's say you didn't have your 45-degree triangle in quadrant 1. Let's say you flipped it and you put it over here. If you make a mirror image of it, does it change the lengths of any of the sides? No. They're both root 2 over 2 still. The only difference is now one is negative. So when you do a 45-degree angle in another quadrant, you're still using root 2 over 2, root 2 over 2. The only difference is sometimes one of them is negative, or if you drew it down here, they would both be negative, or in quadrant 4, one of the other ones would be negative. That's why I said you don't really need to memorize other numbers for this one. It's just positives and negatives. We'll practice some examples, but I'm just kind of showing you the idea. It's like mirror imaging it into other quadrants. All right. So the last two we have are connected, because if I want to look at a 30-degree angle, I'm really looking at a 60 at the same time, because 30 and 60 are in the same triangle, because 30, 60, and 90 add up to 180. So we only need one triangle to figure out both of those coordinates. Let's start with let me put this one in red. Let's start with the triangle in red. So that's the triangle that's laying down on the long side. One of the sides here I already know. What side do I already know? And I drew the one in red. I drew it bigger off to the left. Yep.
You know the hypotenuse.
I know the hypotenuse again is what?
1.
It's 1. But what I need to figure out is how far to the right do you go? And then how far up do you go, starting from the origin, to get to 30? Now, is this an isosceles triangle? Okay? No. All the angles are different, which means all the sides are different. So if you wanted to do it like we did the last one, just watch this for a second. You'd have to use different letters. Well, the problem with that is now if you plug it into Pythagorean Theorem, you've got two variables going at the same time. You can't really figure that out. You can only have one variable. So you still need to use Pythagorean Theorem, but you've got to figure out one of these other sides a different way first. Okay? And my hint, it's kind of just a little trick. I think it'll make sense once I show you. Is to make a copy of it. Okay? It's a temporary copy. I'm not going to need it after I do this. But does anyone have a guess what I'm going to do with that copy? And it's going to allow me to figure something out. Yep. I'm going to flip it. And there's a couple ways I could flip it, but I'm going to flip it this way. What did I just create? I just created a big triangle. And what kind of triangle is it? Equilateral. 60, 60, 60. So that means, what does equilateral mean? All the sides are the same. So this is 1. We already knew that. This is 1. We already knew that. But here's the important part. This is 1. From the top to the bottom on that side is 1. Now what do we know about this part and this part? What do we know of? Well, we don't know the half yet, but what do we know right before that step?
The two pieces combined, which are equally, the two parts are the same length.
These are the same length, right? It's a mirror image. So the red segment and the blue segment are identical, right? The fact that they're identical and they add up to 1 tells you how long each one of them is. So now we know each one of them is how long? 1/2. So now we just figured out one of those other sides using a little trick, and now we can finish it with the Pythagorean Theorem and get the third side. So we don't need this extra triangle anymore. I mean, you can keep it, but. So the bottom side we don't know. You can call it whatever you want. Now when you plug into Pythagorean Theorem, you're only going to have one letter. Okay, so let's set that up. So x squared plus a half squared equals 1 squared, but that's just 1. A half squared means a half times a half. What's half of a half? 1/4. And how would you put the 1/4 over on the other side with the 1?
Subtract it.
Subtract it. If you have 1 and you take away a quarter, what are you left with?
3/4.
3/4. And my last step to get x would be
Square root.
square root it. Square root of 3 I can't really do anything with, but the square root of 4 I can, and that's good because it's in the bottom, and it's going to be a nice number. So what ends up in the bottom? 2. Look at the two numbers that we're dealing with. This side is the square root of 3 over 2. This side is a half. If I go back to something we did earlier, square root of 3 over 2 and a half. You already saw those coordinates earlier. You didn't know what they were about, but the arithmetic you've done here is already the kind of problem you're doing in the next section. You just didn't know where these numbers came from. Now you do, I hope. So let's write down our coordinate for 30 degrees. How long is the bottom side? Square root of 3 over 2. Bless you. That's your x. How tall is the triangle? 1/2. Okay. The way I remember which one is which, the long side is always the square root of 3 over 2. The short side is always 1/2. That's how it always works. The long side is the square root of 3 over 2, and the short side is a half. It's because if you typed it in on the calculator, the square root of 3 divided by 2 is about 0.8, and 1/2 is 0.5. Square root of 3 over 2 is a bigger number. It gets the bigger side. 1/2 is a smaller number. It gets the shorter side. Now, I said that there were 3 numbers you had to memorize. Root 2 over 2. And here's the other ones, root 3 over 2 and 1/2. So we already know every number we need, including the ones to get the 60. What's the difference between the 30 and the 60 triangle? Yeah, it's the same triangle. It's just like you've stood it up straight instead of laying it down on the long side. So the long side becomes up and down, and the short side, which was up and down, becomes left and right. So what does that mean? What happens to your x and y values? They just switch. So 1/2 root 3 over 2. And that's the coordinate for 60. So short side is right there. That gets the 1/2. The long side, the tall side is the y. And that gets the big number, square root 3 over 2. Any questions on those 2 coordinates? So we'll finish up with an example of one of those, and I think we'll save the multiples for tomorrow. And you'll actually like that I'm doing this one because I'll show you why in a second. But you'll be happy I'm doing it. Very happy. Okay, I want to do unit circle trig, but what's the problem here? I don't have a coordinate. Now this is one that we should just look it up or memorize it. We shouldn't go back through and ever figure out all that stuff all over again. What's the coordinate for 45 degrees? Yep, square root of 2 over 2, square root of 2 over 2. That coordinate should look familiar. It should look familiar because it's one of the questions in the homework.
That's why.
So square root 2 over 2, square root 2 over 2, I want you to find the 6 trig functions of that coordinate. We're doing that right now. So start with the sine. Okay, what's the sine?
Square root 2 over 2.
And which letter is it? Even though they're the same, if you mix them up, you'd be okay. But it's the y. In general, if you mix them up, it's wrong. So that's your y. What about your cosine? It's the x, which is the same thing. Now, because the y and the x are the same, that makes the tangent easy to find because you're supposed to divide them. Well, if you divide two things that are the same, what do you get? 1. And while we're at it, let's do the cotangent because that's an easy one to do. If you flip 1, what do you get? 1. All right. Now to get the cosecant, what are we going to flip to do that? We're going to flip the sine. And what do you get when you flip the sine? 2 over what? Over square root of 2. When we had something like that earlier, we got to fix it by doing what? Multiply by square root of 2. And that gives me 2 square root of 2 over 2. And what happens there? The 2's on the outside cancel out, and all you're left with is square root of 2. Now, the secant should be very quick to find because the sine and the cosine are the same. So what's the secant? It's also square root of 2. So there's your six trig functions of 45 degrees, and that's one of the homework questions. Questions on that? All right. Okay, so the homework tonight, I'm not going to give you any of the new stuff yet because we didn't really get into part 2 that much. We only did one example. So I'd like you to find on page 335, find the coordinates for 1, 5, and 8. That's the directions in the book. But then after you get the coordinate, I want you to do what we did in class. Find the 6 trig functions. And I want you to find the 6 trig functions of 3 pi over 2 and 2 pi. Now the problem is I didn't give you the coordinate. So you've got to figure out the coordinate for 3 pi over 2 and 2 pi first. The last one, I gave you the coordinate, but we kind of already just did that. So we'll take a look at that tomorrow, and you should probably have about 25 or 30 minutes, depending on how many homework questions there are at the end of class tomorrow.
Devin, who you in the